Okay guys, today's class we're covering some polyatomic ions that follow a pattern that's easy to recognize, and that's the first ones I'm going to teach you. So there are a couple of tips and tricks that you need to memorize them. The easiest ones to memorize follow a very set pattern. They have prefixes and suffixes to tell you what the structure of the polyatomic ion is. So the first 15 I'm going to teach you all have a -1 charge. And if they have 4 oxygens attached to the atom, they end in 8 and they have a prefix pair. If they have 3, they end in 8. If they have 2, they end in ite. If they have 1 oxygen, they end in ite and they have a prefix hypo. And if they have no oxygen, they end in ide. In fact, any ion that has no other atom attached to it, and if it has a negative charge, it ends in ide. See, chloride, bromide, iodide, fluoride is another one. So the first 15 ions you can easily memorize by following this pattern are perchlorate, chlorate, chloride, hypochlorite, and chloride, and the same pattern for the bromates and the iodates. So IO4 minus is periodate, IO3 minus is iodate, iodide, hypoiodite, and iodide. Nitrate and nitrite still follow the pattern, but there's no other forms of it. I don't think these other ones exist. These ones I know do exist. They're fairly good oxidizing agents. They're also added to food to preserve them against bacteria. So when you eat hot dogs, you're eating nitrates or nitrites. Probably not a good idea to barbecue things like hot dogs because of the presence of these substances, which can combine with the meat to form carcinogens. So normally the best way to deal with hot dogs and things like that is to boil them, because they're very water soluble, so they wash out. So you could pre-boil it, and then if you want, barbecue it, but get the nitrates to come out by putting them in water. Note the prefixes and suffixes then for these 15, because that right away you'll have memorized 15 plus these two, 17 right off the top of your head with very little effort if you can recognize the pattern. And it applies to the chlorates, the bromates, and the iodates. For positively charged ions, which are not polyatomic but are transition metals, some of them can take on more than 1 charge. So what scientists have done is they've added 2 possible suffixes, us and ik. So the lower charged one is always ending in us, O-U-S, and the higher charged one is always ending in ik. So for example, and of course, do not assume it's always the same charges. Sometimes you can have +1 and +2, you can have +2 and +4, you can have +2 and +3. You see all the possibilities there. So the best thing is to memorize them. There's still place for memorization in learning. Some things just need to be memorized for it to work better. And obviously you can use tricks to help you memorize, but at some point you have to do the grunt work. So plumbus, plumbic gives you +2 charged lead and +4 charged lead. Cuprous and cupric is for copper with a +1 or a +2. Chromus and chromic is for +2 and +3 chromium. Cobalt can be cobaltous or cobaltic. Ferrous and ferric, mercurous and mercuric. Notice about mercury that the mercurous cation is basically 2 mercury ions stuck together, each with a +1 charge. So the total charge is +2. Or you can have mercuric, where that +2 charge is on 1 atom. And then you have stannous and stannic with +2 and +4. Now there are other ions that don't follow the same set pattern as we have here, but they still do have some pattern, and that can help you memorize them. The ones that don't follow as set a pattern are the sulfates. For example, you have sulfate with 4 oxygens, sulfite, but with 3 oxygens. If you add hydrogen to it, you get hydrogen sulfate and hydrogen sulfite. These are also called bisulfate and bisulfite. You can call them that. I'll write it down for you if you want. It's less, so bisulfate is an alternate name for this ion, and you can call this one bisulfite. Both of them are. You can use either this one or that one. If you have SO5, it's a peroxide. It's a peroxomonosulfate, which means there's 2 oxygen atoms stuck together in that molecule, and it tends to oxidize other molecules, just like peroxide, which is similar to water molecule, except it has two oxygens stuck together. Every time you have peroxo in the name, this structure exists where two oxygen atoms are stuck together, and they have the capacity of oxidizing substances. Peroxide, for instance, is used for decolorizing stains or for decolorizing hair. If you want to make your hair go blonde from some darker shade, you can add peroxide, but you don't want to overdo it because it can actually also attack the hair. They add oxidizing substances to drain cleaner, for instance. If you take sodium hydroxide, okay, sodium hydroxide, and you mix it with sodium hypochlorite, which is what we use for bleach, mix these two chemicals together, you get Drano, and Drano will dissolve hair. So if you have a clog of hair in your drain, these two chemicals add it, within 15 minutes, the drain will, the hair will just dissolve and wash away, and it'll unblock your drain. Continuing then, sulfide is if you have a -2 charge on sulfur. Remember what I told you, when you have the atom by itself, it always ends in "ide." So if it's just that one atom by itself, it ends in "ide." If you have two sulfurs stuck together, you call it disulfide. Then you have the multiple possibilities of oxygen being stuck to sulfur. You have peroxo disulfate, dithionate, dithionite, thiosulfate, thiosulfite. Then we're going to look at phosphorus polyatomic ions. We have phosphate and phosphite. So 8 is with 4 oxygens. See, it kind of breaks the pattern because before we had perchlorate when it had 4 oxygens, but phosphate has 4 oxygens and it's only called phosphate. There's no per. If you have 3 oxygens, it's called phosphite. 2 oxygens, hypophosphite. Notice they all are -3. So that makes it easier to remember if you notice that all 3 in this series are -3. Then if you have no oxygens, it ends in "ide," like I've said before, phosphide. And if you have P2O7 with a -4 charge, it's called pyrophosphate. Similar to phosphate is hydrogen phosphate. You've just added 1 hydrogen with a +1 charge, so it brings the charge overall down to -2. If you add a hydrogen to phosphite, you get hydrogen phosphite. And if you have 2 hydrogens to phosphite, you get dihydrogen phosphite. And notice the charge drops by 1 each time you add an extra hydrogen. And that covers the polyatomic ions for now.